Factories didn't just get faster, they crossed a line humans can't cross back from. A six-armed robot is now outworking entire teams. A humanoid learned to walk in just 48 hours. MIT figured out how to turn spoken words into real physical objects. And in China, an AI traffic cop is already directing real cars on real streets. None of this is a concept demo. None of it is vaporware. These systems are deploying in the real world right now. And when you zoom out, what you're really seeing is AI no longer waiting for permission to enter the physical world. Let's start in China, because this is where the shift becomes impossible to ignore. At the Greater Bay Area New Economy Forum on December 5th, Medea Group quietly unveiled a robot that signals a turning point for industrial robotics. It's called MiroU, and calling it a humanoid almost undersells what it actually is. MiroU has a human-aligned head and torso, so it fits seamlessly into factory workstations designed for people. But instead of 2 arms, it has 6 fully actuated bionic limbs. That alone tells you this robot wasn't built to imitate humans. It was built to outperform them. The robot moves on a wheeled chassis, not legs. Wheels mean speed, stability, and zero concern about balance. On top of that, base sits a vertical lifting system that allows smooth height adjustment, plus full 360-degree rotation in place. MiroU can spin, lift, reach, and swap tools without ever needing to reposition its entire body. According to Medea's vice president and CTO, Wei Chang, the robot deliberately breaks away from the industry's obsession with human mimicry. His message was clear. Real value comes from operational efficiency, not copying human form. And that philosophy is baked directly into the design. This isn't a lab demo meant to look futuristic. MiroU is already scheduled to roll into Medea's high-end washing machine factory in Jiangsu province by the end of this month. Not next year, not someday. This month. Medea expects the robot to boost production line changeover efficiency by around 30% once fully integrated. That number matters because changeovers are where factories lose time, money, and consistency. Usually, these transitions require multiple workers or machines. MiroU handles them alone, eliminating entire bottlenecks in the process. This launch also reveals Medea's long-term strategy. The company has split its humanoid development into 2 tracks. The Miro series is focused purely on industrial applications, while a second line called MEA is designed for lighter-duty service roles in retail and commercial environments, with deployment planned for 2026. Now, let's jump continents, because something very different but equally revealing just happened in the UK. A London-based company called Humanoid unveiled its first bipedal robot, the HMND-01 Alpha. The headline number alone grabbed attention. This robot learned how to walk just 48 hours after final assembly. Humans take about a year to walk. Most humanoid robots take weeks or months of tuning. Alpha did it in 2 days. Even more impressive, the entire project moved at unprecedented speed. From initial design to working prototype took just 5 months, compared to an industry average of 18 to 24 months. That speed came from heavy reliance on simulation. Humanoid used NVIDIA's Isaac Sim and Isaac Lab to compress roughly 19 months of conventional locomotion training into just 2 days of virtual reinforcement learning. By the time Alpha stood up in the real world, it had already accumulated millions of seconds of simulated experience. Physically, Alpha stands about 5 foot 10 inches tall and can carry a 15-kilogram payload. It has 29 degrees of freedom and modular hands that can be swapped between dexterous 5-finger designs or simple parallel grippers depending on the task. The sensor suite is dense, combining cameras, depth sensors, microphones, haptics, and force-torque feedback. All of this runs on NVIDIA Jetson Orin AGX hardware paired with Intel processors. Power comes from a swappable battery system, delivering about 3 hours of runtime, which is clearly aimed at testing and development rather than full-day deployment, at least for now. According to the company's CEO, Alpha can walk straight and curved paths, turn in place, sidestep, squat, hop, run, recover from pushes, and perform precise manipulation. In simulation, it trained on more than 52 million seconds of locomotion data. In the real world, it required minimal fine-tuning to handle external forces. What's important context here is that this isn't humanoid's first robot. The company previously launched a wheeled mobile manipulator, also called Alpha. That decision was deliberate. Wheels reach market faster, rely on established safety principles, and work perfectly well in most real-world environments. Warehouses are flat, items are lightweight. Legs simply aren't required for most tasks. The lessons learned from the wheeled platform fed directly into the bipedal version. Humanoid designed its systems with modularity from day one, reusing key components and shaving months off development time. On the business side, Humanoid was founded in 2024 and has raised $50 million in founder-led capital. The company reports nearly 20,000 pre-orders and is already fully booked for early 2026 proof-of-concept deployments, while emphasizing safety and compliance with EU regulations. Now let's shift from robots to creation itself. Researchers at MIT have built what they describe as a speech-to-reality system. The idea is simple but powerful. You verbally describe an object, and the system creates it, physically. This isn't a 3D render, it's a real object. The system combines speech recognition, large language models, 3D generative AI, geometric processing, and robotic fabrication. Language becomes design. Design becomes structure. Structure becomes matter. So far, the system has produced functional furniture like stools, shelves, chairs, and tables, along with decorative objects. The implication is clear. This isn't about replacing factories overnight. It's about collapsing the distance between idea and object. Text to image collapsed creative timelines. Text to video did the same. Speech to object does it for physical goods, especially in prototyping, customization, and small batch manufacturing. And finally, all of this has reached public streets. In Hangzhou, a humanoid traffic robot called Hangjing No. 1 is officially on duty at a real intersection. This isn't a demo zone. It's live traffic. The robot synchronizes with traffic lights, uses precise gestures to guide vehicles and pedestrians, and detects violations like helmet non-compliance and illegal parking. It adjusts behavior based on real-time conditions and issues polite reminders. Field testing began months ago, and expansion is already planned for major areas across the city. Future upgrades will integrate large language models for voice interaction, routing queries, and safety education. Authorities are even exploring a full AI traffic management robot team. At this point, nothing about this feels experimental. Factories are deploying, humanoids are shipping, speech is becoming objects. Robots are managing streets. AI has crossed from digital intelligence into physical authority. And that changes everything.